Good day everyone, welcome back to the channel. So in this video we are going to talk about the advanced keyboard tricks in the Linux terminal. Unix is often referred as the preferred operating system for keyboard enthusiasts. The presence of a command line in Unix underscores this idea. Interestingly, despite being command line users, the preference is not for excessive typing. This is evident in the succinct names of many commands like cp, ls, mv, and the rm command. The command line culture values efficiency, aiming to accomplishing tasks with minimum or minimal keystrokes. Embracing laziness, the primary aim is maximum output with the minimum input. Moreover, the allure lies in never having to shift from keyboard to mouse. This chapter explores bash functionalities that enhances speed and efficiency in keyboard usage. These commands are set to appear in this lesson. The first command is clear, which clears the screen. History displays the contents of the history list. Okay, so command line editing. Bash utilizes a library known as readline, which integrates command line editing capabilities as we have previously observed. While the arrow key navigate the cursor, there's a plethora of additional features available. Consider these are supplementary tools for our tasks. It's not necessary to master them all, but plenty are highly beneficial. Select and adopt those that suits your needs.
Unlock the world of Daisy Ninja puzzle books, where excitement meets brain power. Dive into the mind-bending labyrinths of Maze Mastermind. Conquer the Sudoku challenges in Sudoku Ultimate. Uncover hidden words in Word Search Wizard, and decode mysteries in Word Spy Adventures. Whether you're soaring above the clouds or speeding down the tracks, turn your downtime into brain-boosting fun. Perfect for all ages, these books guarantee hours of entertainment. Daisy Ninja Puzzle Books, your passport to endless excitement on the go. New release each month.
So just note certain key sequences outlined below, especially those involving the Alt key, might be intercepted by the GUI as alternate function. However, when operating within a virtual console, all key sequences should function as intended. So let's talk about cursor movement. The following table lists the keys used to move the cursor. Control A, move the cursor at the beginning of the line. Control E moves the cursor to the end of the line. Control F moves the cursor forward one character, same as the right arrow key. Control B moves the cursor backwards by one character, same as the left arrow key. Alt F moves the cursor forward by one word. Alt B moves the cursor backward one word. Control L clears the screen and move the cursor at the top left corner. The clear command does the same thing. So let's quickly check out some examples. We'll quickly type a sentence. Hi, this is the development Rishi channel. Let's just change it to this is development Rishi. And now if we use the Control A, I'm going to press the Control A key. The cursor has moved at the beginning of the line. And if I press Control plus E, the cursor has moved to the end of the line. Now, if I press the Control F key, first I'll move the cursor here. If I press the Control F key, the cursor moves towards the right. And if I press the Control B key, the cursor moves towards the left. Alt F moves cursor forward by one word. So Alt plus F is moving the cursor by one word, and Alt B is moving the cursor by one word. Okay, so let's talk about modifying texts. Control D deletes the character at the cursor location. So this is some text. If we press Control D, nothing has happened. But now if we move the cursor back and then press Control D, it has deleted the last character. It's similar to pressing the delete key. Control T transpose exchange the character at the cursor location with the one preceding it. Okay, so if we say Control T, these two characters. The E is swapping the character on its right and moving forward. All right. So Control L, convert the character from the cursor location to the end of the word to lowercase. So Control L, sorry, I meant Alt L, moves the cursor to the end of the word. All right. So Alt U converts the character from the cursor location to the end of the word in uppercase. So if we say Alt U, see all the words are turning uppercase. Okay, so cutting and pasting, killing and yanking the text. In the read line documentation, the terms killing and yanking are used instead of the common cutting and pasting. While items are cut, they are stored in a buffer known as the kill ring. So let's look at the examples. The Control K, kill text from the cursor location to the end of the line. Control U, kill the text from the cursor location to the beginning of the line. Alt D, kill the text from the cursor location to the end of the current word. Alt backspace, kill text from the cursor location to the beginning of the current word. If the cursor is at the beginning of a word, kill the previous word. Control Y, yank the text from the kill ring and insert it at the cursor location. I want you guys to try these commands out by yourself. They are pretty easy. Okay, so the meta key, delving into the readline documentation located in the readline section of the bash manual, you'll encounter the term meta key. On contemporary keyboards, this corresponds to the Alt key, but this wasn't always the case in an era preceding personal computers. But following Unix, not everyone owned a computer. Some had terminals. Instead, terminals were communication devices with a text display screen and a keyboard linked typically via serial cable to a large computer or its communication network. These terminals, varying in brands and keyboard configurations, functioned with diverse display features. Given the variation, software developers aimed for compatibility by writing applications based on the universal ASCII understanding. Unix systems developed sophisticated methods to manage terminals and their diverse display attributes. Considering the uncertainty of a dedicated control key or terminals, the developers of readline invented one known as meta. Although the modern Alt key functions as the same meta key on the keyboards today, using the escape key when operating on a terminal, which is still viable in Linux, replicates the effect of holding down the Alt key. Completion. The shell offers assistance through a feature known as completion. This function activates when you press the tab key while entering a command. Let's explore its functionality. Consider a home directory structure like this. So our home directory looks like this. Let's try typing ls, then we'll say T, and now I will press the tab key. So as you can see, the terminal filled up the word by itself. This only happens when there is one file or directory name that starts with the letter that was provided by the user. If there were multiple file names with the same character, it won't work. So for example, if we do lsd and we press the tab twice, it'll show all the directories that starts with a D, but you have to choose. You have to be more specific. So for example, we want to select documents. So when we pass the O character next to the D and then we press the tab key, we'll get the documents folder selected. Observe how the shell filled in the line. Let's attempt another one once more, refraining from pressing the enter key just yet. So as we saw, we'll say ls space D and we press tab. No completion occurred as we saw, but if you press tab again, it'll display all the files and folders starting with D. And if you have the speakers on, you'll hear a beep sound. Okay, this occurred because D matches multiple entries in the directory. Successful completion requires an unambiguous clue to be provided. Let's explore further. So as I showed you, if you change it to DO, then press the tab key, you'll see the ls documents directory to be selected. Okay, the completion is now successful. In this instance, we observed completion of path names, the most typical application. However, completion extends beyond path names. It functions on variables when starting with the $, user names beginning with the tilde, character, commands as the first word of the line, and the host names when initiated with the at character. Notably, host name completion solely operates for the host name documented in /etc/hosts. Several key sequences, both control and meta, are linked to the completion features. Key Alt and the question mark action displays list of possible completions on most systems. You can also do this by pressing the tab key a second time, which is much easier. Alt star inserts all possible completions. This is useful when you want to use more than one possible match. There are several more that I consider rather obscure. You can find a comprehensive list in the bash manual under the readline section. Programmable completion. Recent iterations of bash include a feature known as a programmable completion. This functionality permits you, or more commonly your distribution provider, to incorporate extra completion rules. Typically, this enhancement is utilized to extend support of specific applications. For instance, it enables the addition of completions of commands option list or the recognition of particular file types supported by an application. Ubuntu, as an example, already contains a sizable default set. Programmable completion operates through shell functions, a type of concise shell script we'll discuss in upcoming chapters. If you are curious, try the following command, which is set pipe less, and check if you can locate them. However, not all distributions include these by default. All right. So if you're curious, you may use the following command. Using history. As we explored in chapter 1, bash retains a record of entered commands in a file name called .bash_history within your home directory. This collection of commands serves as a valuable asset, significantly cutting down the amount of typing required, particularly when coupled with command line editing. Searching history at any time, we can view the contents of the history list by using the following command, and we can say history, pipe it to the list command, and these are the commands that we used in the session. So pressing Q will quit out of the history. As a default setting, bash retains the most recent 500 commands you have input. We'll explore how to modify these value in a subsequent chapter. Suppose we aim to locate the commands used to list /usr/bin. One method to achieve this is we'll say history, then we'll filter using the grep command, then we'll pass the argument /usr/bin, and all the commands that had this value in it will be displayed with the number in front of it. Okay, now suppose within our results we come across a line containing an intriguing command like this, which is ls-l/user/bin, and using this character, putting all the output from this character to this file. The 88 signifies the line number of the command in the history list. We can swiftly utilize this using another form of expansion known as history expansion. To employ our discovered line, we could execute it with the following command. So because we don't have this particular command in the history, what we'll do, we'll use a different number, which was 108, to utilize this particular command. So as you can see, it has displayed the history again. So if we say !55, it is going to display the content of this particular command. Bash will interpret the !88 as the content of the 88 line within the history list. We'll delve into other types of history expansion shortly. Bash also offers the compatibility to incrementally search through the history list. This allows us to instruct bash to search the history list while entering characters, refining the search with each additional character. To initiate an incremental search, press Ctrl-R followed by the text you are seeking. Once found, you can press enter to execute the command, or Ctrl-J to copy the line from the history list to the current command line. To locate the next occurrence of the text advancing up the history list, press Ctrl-R again to stop the search. Use either Ctrl-G or Ctrl-C. Okay, so here's the demonstration. So now we have the empty command line. So if we press Ctrl R, we see this. Now the prompt alters to signify the ongoing reverse incremental search. It's termed reverse because we are searching from the current moment backwards in time. Following that, we begin typing our search text such as /user/bin in this example. So we'll say ls-l, and we found this command, but I doubt we had that command in our system. Okay, so in this case, we are going to utilize the ls-l. Then we can just continue typing to words.txt. And if we press the tab key, it is going to put it back on the shell. All right. Instantly, the search yields a desired result. With this outcome, we can execute the command by hitting the enter or copy it to our current command line, or for additional editing, pressing Ctrl J. Let's opt to copying it. Press Ctrl J. You can either press Ctrl J, or you can also press the tab key and it'll bring the command to the shell. So let's check it out. We'll say ls-l, and this is the key. This is the command that we found. Let's press Ctrl J. Now it has put the command to the command line. Shell prompt reappears and our command line is prepared and ready for action. Below is the table detailing several keystrokes utilized to manage the history list. Okay, Control P moves to the previous history entry. Same action as the up arrow key. Control N moves to the next history entry. Same as the down arrow key. Alt and the less than sign moved to the beginning or the top of the history list. Alt greater sign move to the end or the bottom of the list. That is the current command line. Control R reverse incremental search incrementally from the current command line up the history list. Alt P reverse search non-incremental. With this key, type in the search string and press enter before the search is performed. Alt N forward search non-incremental. Control O execute the current item in the history list and advance to the next one. This is handy if you are trying to re-execute a sequence of commands in the history list. Now, history expansion. The shell provides a distinct form of expansion for elements within the history list using the exclamation character. We have previously explored how the exclamation point followed by a number can insert an entry from the history list. There are several other expansion functionalities available. Okay, so double exclamation marks or exclamation points repeat the last command. It is probably easier to press the up arrow and enter. And the exclamation number repeats history list item number, as we saw with the exclamation number 88, and the exclamation string repeats the last history list item starting with string. Exclamation question mark string repeats the last history item containing the given string. Okay, I would advise exercising caution when employing the exclamation string and question mark string formats unless you are entirely certain about the contents of the history list items. There are numerous other elements within the history expansion mechanism, but delving deeper might be overly complex and our heads could potentially explode if we persist. For a comprehensive understanding, refer to the history expansion section in the Bash manual. It covers all the intricate details. Feel free to explore further. Okay, the script, aside from the command history feature within Bash, the majority of Linux distribution incorporate a program named script, which captures and saves an entire shell session into a file. The command's fundamental syntax is script, then the name of the file. Here, file represents the designated name for storing the recording. If no file is specified, the default file name file type script is used. For a comprehensive overview of the program's options and functionalities, refer to the script man page. Let's sum up the chapter. Throughout this chapter, we have delved into various keyboard techniques offered by the shell aimed at aiding dedicated typists in lightening their workloads. I anticipate that as you spend more time navigating the command line, you might revisit this chapter to acquire additional tricks. At this stage, regard them as optional but potentially advantageous. Okay, guys, so do go through the chapter. Do practice these commands and do practice those that I have not showed you here. I'll have left them for you to practice. And in the meantime, have a good one. And the notes for this chapter are linked in the description. And I will see you in the next video. Take care. Bye-bye.